Good morning. In this video, we are going to discuss the second chapter in chemistry, gas laws and mole concept. Before discussing the gas laws, we have to freshen up on some of the physical properties of gases. The first one is volume. We know that gases doesn't have a definite volume. The volume of a gas is the volume of the container which it occupies. If the gas is taken in a large container, the gas will expand itself to large volume. The next property is pressure of the gas. Since the gaseous molecules always are moving, there is a huge chance of collision with each other and also with the surface of the container. Because of this collision, a force is experienced on the surface of the container. And the pressure of a gas is force on unit area. So it can be calculated as total force exerted on the surface divided by surface area. The molecules in gases are always moving. So they are bound to have kinetic energy. Temperature is the average kinetic energy of molecules in a substance. Now take the example of a gas taken in a closed container with a piston. What happens when the volume is reduced? We can see that the collision with each other and the collision with surface increase as we decrease the volume. That is, the pressure, which is force exerted per unit area, is increased while we decrease the volume. Or we can say the pressure is small when the volume is large. That is, pressure and volume of a gas are inversely proportional when the temperature is kept constant. This relationship between pressure and volume is given as Boyle's law. It states that at constant temperature, volume of a definite mass of gas is inversely proportional to its pressure. Or if we denote pressure as P and volume as V, at constant temperature, P into V will always be a constant. Now, you might have seen an inflated balloon kept in sunlight burst after some time. Why is it happening? In order to understand that, we are going to analyze the relationship between volume and temperature of a gas. Now, take the example of a gas taken in a container with freely moving piston at one side. We can see that when it is heated, the gas expands and the volume increases. So, at lower temperature, the volume will be less, and at higher temperature, the volume will be more. That is given as Charles' law. It states that at constant pressure, the volume of a definite mass of a gas is directly proportional to the temperature in Kelvin scale, or V by T is equal to a constant. Now, the Avogadro's law states that at constant temperature and pressure, the volume of a gas is directly proportional to the number of molecules. That is, when the temperature and pressure are constant, the volume of gas will only depend on the number of molecules. If the number of molecules is greater, then the volume also will be greater. And if the number of molecules is less, the volume also will be less. Then the question arises, how can we find out the number of molecules in a gas? If we are given a particular mass of substance, we can find out the number of particles in it by dividing the mass of that substance with mass of one particle, right? So, in order to find out the number of molecules in a gas, we just have to know the mass of that gas and also mass of one molecule. We always say that atomic mass of hydrogen is 1, helium is 4, nitrogen is 14 and so on. But these are not the real masses of one atom. These are all relative atomic masses. That is, the mass of one atom is Z compared to mass of another atom. Here, the atomic mass of elements are expressed by considering 1 by 12 mass of an atom of carbon 12 as one unit. That is why most of these values are whole numbers. And these atomic masses, when expressed in grams, is equal to 1 GAM or 1 gram atom. And 1 GAM of any element contains 6.022 into 10 raised to 23 number of atoms in it. This number is known as Avogadro's number. So the number of GAM or gram atom is given as given mass in grams divided by GAM of the element. We know that GAM is the atomic mass in grams, so it can also be considered as given mass divided by atomic mass. We know that 1 GAM contains Avogadro number of atoms in it. So number of atoms in a sample can be given as number of GAM into Avogadro number. In the same way, the mass in grams equal to the molecular mass of the substance is called gram molecular mass (GMM) of that substance. Just like in the case of GAM, 1 GMM also contains Avogadro number of particles. So 1 GMM is equal to Avogadro number of molecules. And just like we found out the number of GAMs, we can find out the number of GMM as given mass in grams divided by GMM. And GMM is equal to molecular mass in grams. So the number of molecules is equal to number of GMM into Avogadro's number. Mole is the SI unit which is used to denote the amount of substance which contains Avogadro number of particles. That is, 1 mole of atoms is Avogadro number of atoms and 1 mole of molecules is Avogadro number of molecules. So we can say that 1 GMM is equal to 1 mole, which is equal to 6.022 into 10 raised to 23 molecules or Avogadro number of molecules. So 1 mole of any gas will contain Avogadro number of molecules, right? Then under same conditions of temperature and pressure, 1 mole of any gas will be having same number of molecules and hence their volume also will be the same. And if that conditions are 273 Kelvin temperature and 1 atm pressure, 1 mole of any gas will have 22.4 liter volume. These conditions of 273 Kelvin temperature and 1 atm pressure is known as STP or standard temperature and pressure. And the volume of 1 mole of gas at STP, 22.4 liter, is known as molar volume at STP. If we are given the volume of a gas at STP, we can find out the number of moles of that gas as volume in liters at STP divided by 22.4 liter, that is volume of 1 mole. I hope you have all understood the topics discussed here. Thank you.